The QDK is very easy to get installed. In this video, I'll spend the first couple of minutes on the simple version for those of you already familiar with VS Code and Python, and then I'll spend about 5 minutes on a more detailed walkthrough that also covers getting VS Code and Python set up correctly on Windows, Mac, and Linux. First, the simple version. To install the QDK VS Code extension, open VS Code, go to the Extensions area, search on QDK, and install the Microsoft Quantum Development Kit. Installation just takes a couple of seconds. Once installed, the extension gives you an AI-assisted learning experience with extensive content and interactive exercises, rich editor support for Q# and QASM, including built-in samples of some of the most popular algorithms, one-click quantum simulation with interactive histograms, rendering quantum code as interactive circuits, an integrated API documentation browser, a quantum-specific debugger, a circuit editor for building quantum operations using a drag-and-drop experience, submitting jobs to real quantum hardware through the Azure Quantum service, deep GitHub Copilot integration across all of these features for AI development, service management, and much more. To see some of the incredible things you can do with the GitHub Copilot integration, go to aka.ms/qdk.copilot. To install the QDK Python package, run pip install QDK. Include the Jupyter Extra for Jupyter Notebooks integration. The Python packages will give you Q# language support in Jupyter Notebook cells, Python integration with Q# and OpenQASM, advanced resource estimation capabilities for different qubit types and architectures, interactive widgets such as animations of quantum programs running on neutral atom machines, more simulator choices such as a cross-platform GPU simulator and a stabilizer simulator that scales to thousands of qubits, advanced noise modeling such as correlated noise and qubit loss, and much more. To get the QDK for Chemistry package, run pip install QDK-Chemistry and include the Jupyter Extra for Notebooks integration. Now you have libraries and interactive widgets to work with model Hamiltonians, molecule visualizations, and much more. Go to aka.ms/qdk.chemistry for more details. That's the quick version. For the rest of this video, I'll cover getting VS Code, Python, and the QDK set up correctly on Windows, Mac, and Linux. Python environments especially can be tricky even for experienced developers to get working properly, so I'll cover some useful tips and tricks there. First, VS Code. You can download the VS Code package by going to code.visualstudio.com and choosing the package for your platform. However, on Windows, I find the easiest way to install VS Code is to open a terminal and run winget install VS Code. That will run you through the standard installation process, and afterwards you will have VS Code available in your start menu or from the command line. Here, I'll get the macOS installer from the website and run it. Once the package is downloaded, open it and drag the application into the Applications folder. On macOS, the code application doesn't automatically get added to the path. So once installed and running, press Command-Shift-P to open the command palette, search for path, and select Install Code Command to Path. Now it can be launched easily from the terminal. The installation steps differ slightly between Linux distributions. To find the instructions for yours, go to the VS Code online docs. For Ubuntu or Debian, simply download the .deb package, and then from a terminal, run sudo apt install and the deb package you downloaded. The installation will add the repository and key so that it can auto-update going forward. Once installed, you can launch VS Code from the desktop or via the code command from the terminal. Some of the more advanced QDK features, such as Jupyter Notebooks integration, resource estimation, advanced simulator configuration, and more, require the use of the QDK Python packages. The QDK Python packages are published to the Python package index. If you're on Windows, you'll need to decide whether to use Python for Windows or run Python from inside a Windows subsystem for a Linux environment. Some scientific packages are not available for Python for Windows, so if you need to use any of those and are running Windows, you need to use WSL. See the WSL docs at aka.ms/WSL for more info. Here you can see I already have WSL running with the default Ubuntu distribution. If you plan to use Python for Windows, then as with VS Code, I find the easiest way to install is via winget with winget install Python 3. Relaunch the terminal after installation, and running python --version should report the version installed. You can also go to python.org to download and run the Windows and Mac installers the typical way. On macOS, I use Homebrew, which is a very common package manager on the Mac, and with Homebrew, simply run brew install python @3. Once installed, again relaunch the terminal, and python 3 -- version should report the installed version. Python installation differs between Linux distributions. On Ubuntu or Debian, including inside of WSL, run sudo apt update to update the package index, followed by sudo apt install python 3 python3-venv python 3-pip to ensure Python as well as the virtual environment and package manager are available. Once installed, python 3 -- version should report the Python version installed. For Python projects, the best practice is to create a fresh Python virtual environment per project rather than mess with the system default environment. The commands for this differ slightly by platform. On Windows using PowerShell, run python-m venv.venv to create a virtual environment named .venv, and then run the scripts.activate PowerShell script to activate it. On Mac or Linux, including inside WSL, run python 3-m venv.venv to create the virtual environment, and then source the bin activate script from within that environment to activate it. Once the environment is activated, the commands python, pip, and so on will only affect that Python environment and not the global installation. Installing the QDK for use from Python is as simple as pip install QDK. To work with Jupyter notebooks, you want to install the Jupyter package into your environment with pip install Jupyter, or if you'll be working with notebooks only in VS Code, as I typically do, then you only need the Python ikernel package, which you can install with pip install ipykernel, and that's a smaller set of packages. Then install the QDK with the Jupyter extra with pip install QDK and the Jupyter extra in square brackets. You can list multiple QDK package extras depending on the features required. For example, if you'll be working with the quantum resource estimation and Circ, you'll want pip install QDK with the Jupyter, QRE, and Circ listed inside the square brackets. VS Code has extensions for working with Python and Jupyter notebooks, which should be installed along with the QDK. If you're using WSL on Windows, you'll first want to launch VS Code and install the WSL extension. Then close VS Code and launch it again using the code command from within the WSL prompt. When VS Code runs connected to a WSL workspace, it has a front-end part that runs on the Windows OS and a back-end part that runs on the WSL Linux OS. And we want to ensure the following extensions are installed into the WSL backend. To install the Python, Jupyter, and QDK extensions, in VS Code, go to the extensions area and install the Python extension pack, the Jupyter extension pack, and the QDK. Here we'll test that everything is working by opening an empty QSharp file, using a sample from the completion list, and verifying I can run it from the code lens. I also have a sample notebook I created using the QDK create a Microsoft Quantum notebook command from the command palette. Ensure the right virtual environment is active and run a few cells to test that everything is working. And with that, you have VS Code, Python, and the QDK all set up and ready to go. Happy quantum coding!